The James Webb Space Telescope has been finding things out there that should not exist. Not according to our models, not according to decades of settled science. 5 James Webb Space Telescope discoveries when NASA's scientists looked at the data and had no answer. Here's what James Webb Space Telescope found. Number 1. A planet that should be dead, but isn't. Meet TOI 561b. It's twice as old as our Sun. It completes a full orbit in just 10.5 hours. Its surface is literally a global ocean of magma at 3,200 degrees Fahrenheit. Gravity has permanently locked one face of the planet in constant, scorching daylight. By every rule we know, it should be a bare, airless rock. Small rocky planets that close to their stars lose their atmospheres. That's just science. Except TOI 561b has one. A thick one. Scientists know because a bare rock at that distance should be hitting 4,900 degrees. It's running 1,700 degrees cooler than it should be. And that gap can only be explained by an atmosphere spreading the heat around. One scientist described it perfectly. It's really like a wet lava ball. And now we have to completely rethink which rocky planets can hold on to atmospheres, and what that means for finding life elsewhere. Number 2. Strange-shaped planet. PSRJ 2322-2650b is a Jupiter-sized planet orbiting a pulsar, a dead star that spins thousands of times per second. The gravitational forces are so extreme, they've squeezed the planet into the shape of a lemon. Its atmosphere is made of pure molecular carbon, not carbon dioxide, not methane, just raw C2 and C3 molecules floating around in helium. Soot clouds drift through the sky, and deep inside, that carbon compresses and rains down as diamonds. James Webb Telescope has now studied 150 planets. Not one other has atmospheric molecular carbon like this. We cannot explain how it formed. It is, by every formation model we have, impossible. It's a completely new category of world that we didn't know could exist. Number 3. We watched moons being born. Jupiter has 95 moons. Saturn has over 140. We've known about them for centuries, but we had absolutely no idea how gas giants make moons. Until Carnegie astronomer Sierra Grant pointed James Webb Telescope at a baby planet 625 light-years away called CT Chameleontis b. What she found was a swirling disk of gas and dust wrapped around this infant planet. Humanity's first detailed look inside a moon-forming environment. And immediately, something was off. The disk around the planet was packed with 7 different carbon-containing molecules, including benzene. But the disk around its host star? 0. Not a trace of carbon. The planet and its star are sitting in the same solar system, and they're already speaking completely different chemical languages. That discovery single-handedly rewrites what we thought we understood about why Jupiter's moons are so wildly different from each other. Europa has an ocean under its ice. Io is a volcanic nightmare. Titan is drenched in hydrocarbon lakes. Now we know the chemistry can diverge fast, like million years fast. Number 4. Baby galaxies were pulling all-nighters. Carnegie astronomer Alan Dressler, the man who literally chaired the committee that first dreamed up JWST back in the 1990s, used his own telescope to study galaxies from just 2 billion years after the Big Bang. What he found stunned him. These infant galaxies were forming stars at rates that our best models said shouldn't happen that early. The universe was still young, still disorganized, still figuring itself out, and yet nature was cranking out stars like it had somewhere to be. Dressler calls it bursty star formation, like cosmic growth spurts. And there were way more of these galaxies than anyone predicted. This is the first chapter in our origin story, he says. Astrophysicists now have to go back to the drawing board. Number 5. Insane galaxies. Carnegie's Gwen Rudy led a team that stared at 33 teenage galaxies, from 2 to 3 billion years after the Big Bang, for over a day straight with JWST. They were hunting for oxygen. They found oxygen, sulfur, and argon. But here's the twist. Sulfur and argon were weirdly, consistently low across all of them. Those elements come from a specific type of supernova that only happens in more mature galaxies. These early galaxies hadn't lived long enough to produce them yet. They were chemically immature, teenagers who hadn't gone through the right growing pains yet. The project was named Cecilia, after Cecilia Payne-Gaposchkin, who figured out what stars were made of 100 years ago and was dismissed for it. Science has a long memory. So, if you enjoyed this video, make sure to hit that like button, share it with your friends, and don't forget to subscribe for more amazing content.